Welcome to all. Myself Sajithra, lecturer of Emmanuel Eresser College of Pharmacy. In this session, we are seeing about the bioenergetics topic. Bioenergetics. The term bioenergetics is made up of two words. That is, bio means life of living, energetics means study of energy. So, basically, bioenergetics or biochemical thermodynamics deals with the study of energy changes in biochemical reaction in the living body. Energy changes means the transfer and utilization of energy. The reaction are broadly classified into two types. They are exergonic reaction and endergonic reaction. Exergonic reaction means energy releasing and endergonic reaction means energy consuming. The concept of free energy. Free energy is denoted as delta G. The energy actually available to do work known as free energy. Changes in the free energy are valuable in predicting the chemical reactions. Adenosine triphosphate is the main energy currency for the organism. The goal of metabolic and catabolic process are to synthesize ATP from available starting materials and to break down ATP by utilizing it in the biological process. In a cell, the ratio of ATP to ADP concentration is known as the energy charge of the cell. A cell can use this energy charge to relay information about cellular needs. If there is more ATP than ADP available, the cell can use ATP to do work. But if there is more ADP than ATP available, the cell must synthesize ATP via oxidation phosphorylation. Types of bioenergetic reactions. Bioenergetic reactions are classified into two types. They are exergonic reaction and endergonic reaction. First, we see about the exergonic reaction. Exergonic reaction implies the release of energy from a spontaneous chemical reaction without any concomitant utilization of energy. Most of this reaction involves the breaking of bonds during the formation of reaction intermediates as observed during respiratory pathways. The bonds that are created during the formation of metabolites are stronger than the cleaved bonds of the substrate. The release of free energy, that is G, is an exergonic reaction is denoted as the following equation. Delta G equal to G product minus G reactants, which is lesser than the zero. The hydrolysis of ATP is classical example of exergonic reaction. That is ATP plus water molecule which gives ADP plus Pi. If free energy change, that is delta G, is represented by a negative sign, there is a loss of free energy. The reaction is said to be exergonic reaction. Then we see about the endergonic reaction. On the other hand, a positive delta G indicates that energy must be supplied to the reactants. The reaction cannot be pursued spontaneously and is endergonic in character. The reversal of the reaction, that is ADP plus Pi minus plus ATP, is a endergonic and occurs only when there is a supply of energy of at least 7.3 calorie per mole. That is delta G is positive. Then we see about the law of thermodynamics. Bioenergetics is concerned with the change in energy during biochemical process. It does not deal with the mechanism or speed of the process. The thermodynamics is the branch of physical chemistry that deals with the energy changes. There are two fundamental laws of thermodynamics which explain the interconversions of various forms of energy. The first law of thermodynamics. The first law of thermodynamics states that energy can neither be created or destroyed, but can be converted into other forms of energy. It means the total amount of energy in the universe remains constant. Universe means system plus surrounding. That is, E is equal to EB minus EA. According to the above mentioned equation, the change in the energy of a system depends only on the initial and final stages and not the path of the transformations. Then we see about the second law of thermodynamics. The first law of thermodynamics cannot be used to predict the spontaneity or non-spontaneity of the reactions. On the other hand, the second law introduces a term entropy, which is denoted by the symbol S. Entropy is the degree of randomness or disorder of a system and explain whether a reaction takes place spontaneously. Entropy means the amount of heat dispersed or transferred during a chemical process. Then we see about the enthalpy. The enthalpy is denoted as the symbol H. Enthalpy, which is the heat content of the system. Enthalpy is the amount of heat energy transferred in a chemical process under constant pressure. Then we see about the three thermodynamic quantities. There are three types of thermodynamic quantities that are enthalpy, entropy, and free energy. First of all we see about enthalpy. The enthalpy was denoted as the symbol H, and the enthalpy was measured as heat. The unit of enthalpy is energy. Then we see about entropy. Entropy is denoted as the symbol S, and it is measured as disorder. The unit of entropy is energy per K. Then we see about the final thermodynamic quantity, free energy. Free energy is denoted as the symbol G, and the measure is reactivity. The unit of free energy is energy. Then we see about redox potential. Redox potential is also known as oxidation reduction potential. The oxidation reduction potential, or simply redox potential, is a quantitative measure of a tendency of a redox pair to lose or gain electrons. On the other hand, a more positive redox potential indicates a greater tendency to accept electrons. The redox potential is directly related to the change in the free energy. Then we see about energy rich compounds. Certain compounds are encountered in the biological system on hydrolysis which yield energy. The term high energy compound or energy rich compound is usually applied to substance which possess sufficient free energy to liberate at least 7 calorie per mole at pH 7. Certain other compounds which liberate less than 7 calorie per mole than ATP hydrolysis to ADP plus Pi are referred to as low energy compounds. All the high energy compounds, when hydrolyzed, liberate more energy than that of ATP. These include phosphophenol pyruvate 1,3, phosphoglycerate, phosphocreatine, etc. Most of the high energy compound contain phosphate group, hence they are called as high energy phosphate compound. ATP. This ATP is also known as universal currency of free energy. The living organism derive free energy from the environment. The photosynthetic organism that take this energy from the sunlight, whereas hemotrophs obtain it by oxidation of foodstuff. Before being utilized in the above mentioned process, the free energy, that is, the energy derived from the light or from the oxidation of foodstuff, is partly converted into a special form, adenosine triphosphate. ATP is also known as universal currency of free energy. It plays a central role in the transfer of free energy from exergonic process to endergonic process in the cell. During the breakdown of the energy-rich foodstuff, some of the free energy is consumed in synthesis of ATP from adenosine diphosphate and inorganic phosphate. Also, it is converted into AMP. Then we see about the one important second messengers, which is called as cyclic AMP. Cyclic AMP, which is also known as CAMP, it is called as cyclic adenosine 3,5 monophosphate. This cyclic AMP is a type of nucleotide. It consists of adenine, ribosine, ribose, and a phosphate. Cyclic AMP acts as a second messenger for majority of polypeptide hormones. The membrane-bound enzyme adenylate cyclase converts ATP to cyclic AMP. Cyclic AMP is hydrolyzed by phosphodiesterase to 5-AMP. So, thank you for watching my class. Thank you.